elimination that we learned in the previous class, let us learn about substitution method in this class. Substitution is, as the name says, suggest. The first step is find the variable x or y. Okay. Let me pick this line equations.
Okay.
And then what is y is equal to in this?
Y is equal to 7 plus 2x. 7 minus 2x.
7 minus 2x, right?
Yeah.
So find a variable from a line equation. The second step is to substitute that value in other line. So substitute this value in the second line.
Okay. Oh, I see. Okay.
In other line equation.
Yeah, makes sense.
So y is equal to
7 minus 2x.
so 5x plus 3y was 8.
Yeah.
Yeah, this is a bit easy. So you put y value here.
Yeah.
Y was 7 minus
2x.
how many variables do you see now?
2.
It's just one x. In this,
Okay. Yeah. There's yeah.
if there is only one variable, can you find that?
Yeah. It would be 5x plus 21 minus 6x equals 8.
How much is
Then it would be negative x plus 21 equals 8. Yeah.
x is equal to?
Yeah, sorry. X is equal to 13, negative 13.
Positive 13. This is negative 13, right?
Yeah.
Negative x is equal to negative 13.
Yeah. Okay.
So now that you found x, what else can we find?
We can input the x into any of the equations and find our y value.
We know that y is equal to x 7 minus 2x.
Yeah.
So put x here twice of
13. Minus 26, 7 minus 26 equals 19. So y equals negative 19.
so that's it. Y is equal to
Yeah.
19 and x is equal to 13.
Yeah, this seems simpler than the elimination method.
Yeah. So this is substitution method. Basically, you are picking a line equation and from that you are finding one variable and then you are directly substituting into other one. Since you are substituting, the method is known as substitution method. So these are the two methods. Let's talk about few concepts. Similar equations. Let's say there are two lines. 5x plus 3y is equal to 8. 10x plus 6y is equal to 16. Can you try to solve this?
Yeah. Okay. So I'll just use the substitution method only.
Okay.
Okay. So it would be Or actually here, like let's say we were doing substitution here, right? And we're trying to put the y variable by itself. So would we do y is equal to 5x divided by 3?
How is it 5x divided by 3? Okay, why did you add 5x and 8?
Because if we were like doing this, then when we divide the whole thing by 3, they cancel out this 3 term.
So is it 8 plus 5x or what else?
Oh yeah, so
5x is left side, right?
yeah.
So 8 minus 5x.
Yeah.
Yeah, put that. Minus 5x. Now what?
Then we would uh do this, so it would be y equals 8. Yeah. Well, we know this now, so then we could just input this into the equation. So it would be 10x plus 6 is equal to 16.
Yeah, open that.
What?
Open this.
It would be 6, it would be plus. Well, wouldn't we have to divide this first? 8 minus 5x? Because how do we distribute it into a fraction that we don't know?
See, 6 over 3 is what?
2.
So twice of
Twice of 3. Oh, okay.
3 ones
So this is
twice of
8 minus 5x.
which will be
16 minus 25x.
16 minus
Or sorry, 16 minus 10x.
right there. Use a different color, not black.
Okay. So then at the end of the day,
Is equal to
16. So equals x.
okay. Y plus 6.
Plus 16.
You have written here, right? 16.
Yeah.
Then Y again.
Well, I just wanted to clarify that x is equal to 16.
No. Check again.
I mean, if this is cutting out and then we only have 16 remaining, wouldn't that mean x is equal to?
See. Is equal to 16, right? 0x is equal to 0.
Yeah. So x is just 0?
X can be anything. 1, put 1, what happens?
Yeah, it works still.
Any value is working, right?
Yeah.
These types of lines are called similar equations. Actually, if you notice carefully, the first one and second one, if you multiply the first one with 2, what do you get?
10x plus 16, 10x plus 6y equals 16.
Which is the same as?
Yeah, that one. Yes.
That means these lines are same lines. If you draw in the graph, let's say you get a line like this. The first line will be like this. Second line will be also on top of that, the same place. This is the second line, like that. So these types of lines are coinciding lines.
Yeah.
So number of solutions is equal to?
Infinity, like any number of solutions.
So my all points are coinciding, right?
Yeah.
So therefore, the number of points are number of solutions.
Are infinity.
So yeah, these are called similar equations.
Okay.
Let's take a different example. 2x plus y is equal to 1 and 4x plus 2y is equal to 3. Try to solve this.
Yeah. Um. So using substitution method, we can say y equals 1 plus 2x.
1?
1 minus 2x, sorry. Not 1 plus 2x, 1 minus 2x. So then if we put that in, it would be 4, oh, no, 4x plus 2. So it would be 4x plus 2 minus 4x equals 3. So 4x and this cancel out, so 2 doesn't equal 3. So these two lines don't intersect, right?
That means no such x exist
Yeah.
to satisfy the above equation. That means lines do not
Intersect.
number of solutions is equal to
0.
that. Okay, if the lines do not intersect, what type of lines are there?
Ooh, there are parallel lines.
Parallel lines.
Or no, parallel.
Huh?
Yeah. Don't parallel lines mean they have to go like
They are parallel to each other. But do they ever intersect?
No.
So one practical example is this ruler. You see this ruler? If you draw a margin from above and if you draw another line from below,
Yeah, yeah.
will they ever intersect?
No.
That means they are what type of lines?
Parallel lines.
So that means parallel lines. Here, what we need to check to summarize everything, if you want to summarize this point, and everything else, we have to look at coefficients, ratio. What is the ratio here?
The first ratio is 1 to 2, and the second ratio is also 1 to 2.
Y coefficient is also ratio 1 to 2, right?
Yeah.
What is C1 by C2?
What do you mean C1 by C2?
See, ax plus by is equal to c, right?
Yeah.
This c.
Hmm.
The 1 over 3.
Okay.
So 1 over 3. So that means a1 by a2. In this case, notice the ratio.
That's 1 to 2 as well.
What about y?
Also 1 to 2.
What about c1 by c2?
Also 1 to 2.
If all the ratios are equal, what type of lines are there?
Similar equation.
So coinciding lines.
Yeah.
To summarize things, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, lines are
Similar.
what there? If this ratio is not equal to c1 by c2, then
Is not equal to. Oh, lines are parallel.
quad 1. Okay. And we can also mention here number of solutions is equal to write that quick. Okay.
Yeah.
Earlier we have observed what happens if these ratios are equal. So if these ratios are not equal, lines are
Yeah.
intersecting.
Interesting. Yeah.
How many solutions done?
2.
How many?
2.
Just one. Lines are intersecting means what?
They're intersecting at one point.
So number of solutions?
Oh, okay. Just one then. Okay.
Like that. So these 3 points are important. This is called solution of linear systems or solution of system of linear equations.
Mm.
So that's it for this chapter.
Okay. Okay. Do you want me to give you the next?
Yeah.
Okay. The next one is polynomial equations.
Okay, before that, let us do some equations. One question, important question. By the way, Harshit,
Yeah.
in 8th grade, what topics were taught in mathematics?
8th grade, I took geometry. So it was like triangles. We did lots of trigonometry. That was one of the main focuses. Then angles, angle equations, then yeah, lots of trigonometry, then how to find angles in different quadrilaterals, not polynomials, sorry, polygons and things like that. Yeah.
So is it like just pure geometry or geometry plus algebra 1 like that?
There was some algebra 1 in it because of like for example, the a squared plus b squared equals c squared. Like for that, yeah, there was a little bit of algebra, but it was mostly geometry.
Okay. Do you have any idea what is going to be taught in grade 10?
Grade 10, we hang on. We in grade 10 we have I think we have statistics in grade 10. I'm not sure though.
So algebra 1 is completed.
Yeah, algebra is completed.
Algebra 1.
Yeah, that happens in that happened in 7th grade for me.
Okay. So currently it is going on algebra 2.
Yeah. In 6th grade we have intro to algebra. Then 7th grade we have algebra. Then we have algebra 1. Then 8th grade we have geometry. 9th grade we have algebra 2.
How many total subjects for this semester?
You have 8 subjects.
Okay, is it like
Oh, what do you mean by like classes? You mean?
yeah.
Yeah, 8 classes. Well, I'm taking 9 classes currently, but yeah,
So you're doing
minimum. Yeah, I'm doing just because I didn't want to take it. I didn't want to like replace the course with it. I'm taking band early work like in the morning.
Okay, okay. That is nice.
Yeah.
Okay, by the way, do you know this formula?
speeds is equal to
Mass times acceleration. Oh no, mass times acceleration is
force.
yeah. Speed is equal to distance over time.
Distance over time, right?
Yeah.
Do you know the concept of upstream and downstream?
No.
River problems.
No, I don't think we ever did that.
Okay, what about vectors? Chapter.
Yeah, we briefly went over vectors. Not too much in detail.
Okay, speed is vector or scalar.
Yeah, I don't think we covered this. I mean, usually we covered this in um like introduction to physics and chemistry. We didn't cover this in math stuff.
Okay, I'm just asking physics question.
Yeah,
Speed is scalar or vector?
I think it's a vector, but I'm not sure.
Speed is scalar.
Okay,
Velocity is vector.
okay.
Okay, try to do this question. Read this question first.
So canoeists took 2 hours to travel 12 kilometers downriver. The return trip against the current took 3 hours. What was the average paddling rate of the canoeists, and what was the speed of the current? Okay. So the canoeists took 2 hours to travel 12. So we can find the speed of the how fast he was paddling using that. So the distance is 12. It took him 2 hours. So it means he was traveling at a rate of um 6 kilometers per hour. Or yeah.
Okay. One thing you need to notice is this speed
Yeah.
is not just his speed. Because he is traveling in a river, there is also water currents.
Yeah.
So you have to involve that speed also. I'll tell you how to do this. Let's say there is a river like this.
Mm.
So if we travel 12 kilometers, that
Means the length of the river is
12 kilometers.
12 kilometers. So this length, okay, and it is saying that, okay, let's assume the water is flowing in this direction. This is speed of water. Okay, how do you represent the speed? Is it s or is it v?
Speed.
Okay, we
Well, no, since we're doing kilometers, isn't it velocity?
You can take anything. Velocity is means you have to consider the direction.
Oh, okay, yeah.
Difference between scalar and vector is scalar is just a numerical value. Vector is numerical value plus in which direction.
Okay.
I'm just asking that, is it okay if I write S? SW means speed of water.
Yeah, okay.
So let's say water is flowing in right side direction.
Yeah.
The canoeist, it took him 2 hours to travel 12 kilometers down the river.
Yeah.
That means, let's say this is a canoeist.
Mhm.
He's traveling in this direction. Down here. So let's say the speed is SC. SC is equal to speed of canoeist. SW is equal to,
Speed of water. Yeah.
okay. When he is traveling downstream,
Mm-hmm.
it took him 2 hours.
Yeah.
Distance traveled is equal to,
12 kilometers.
when he is traveling down the river,
Yeah.
there are two speeds actually. Speed of canoeist and
The speed of water. Yeah.
they are in both same direction.
Yeah.
So what is the effective speed?
The speed of the canoeist is 6 kilometers per hour, and the speed of the water is 2 kilometers per hour.
2 kilometers per hour, it is not flowed. Where is it?
Oh no, I thought you just wanted me to go ahead and do that.
The thing is, see what is speed? It is magnitude of velocity.
Mm.
So the canoeist is, hello.
Yeah.
Well, I don't know what happened. Suddenly it logged me out.
Okay.
Well, anyway. So let's say speed of canoeist and speed of water. Effective speed, since they are in same directions, what can you do with those vectors?
You can combine them.
So you just add them because same direction.
Mhm.
So the effective speed becomes SC plus SW.
Equals 6.
So SC plus SW is equal to 12 over 2, which is
6.
distance by time is equal to 6 kmph.
Oh, that's figured out. But
Okay, this is when he was traveling down the river.
yeah,
What is the next point?
it says that when he was traveling against the water, so the return trip, it took him 3 hours.
So return trip. Return trip means what?
He was traveling.
Right?
Yep.
He went from left to right. Now he is coming from
Right to left.
right to left. When he is traveling right to left,
Mhm.
his speed and the river speed is
Not the same. It's working against each other.
working against each other, opposite to each other.
Yeah.
So this is the speed of colorist. This is the speed of water. Water speed always remains in the same direction, right?
Yeah, that doesn't change.
Now what is the effective speed?
On the speed. Well, if we don't have any other information, it would be, um, 3 and 3. Well, it would be SC minus SW.
SC minus SW.
Yeah.
See, if I am applying a force of 2 Newton on the right side
Mhm.
and 1 Newton on the left side, someone else is applying,
Mm.
the effective will be 2 minus 1, right?
Yeah.
So it's like that. Opposite direction means you have to subtract the.
Yeah.
Well, yeah, so in the return trip, speed is equal to SC minus
SW.
speed is equal to distance by
Time.
distance was
12. Time was 3 3 hours.
so
4. Yeah, 4 kilometers per hour.
now what is the question actually?
It's asking, well, we already found that. Yeah, so it's asking, like, what does SW equal and what does SC equal, basically. What it's asking.
That's it. Okay, we find SW and
Well, if we know that he is like more powerful than the water because he's still reaching there, right? We can say that we're like, since the his power with the water was 6 kilometers per hour, and then his power coming back was 4 kilometers per hour, and then we could see that the difference with the water and without the water was 2.
well, these are the two equations, right?
Yeah.
How can you find SC and SW now?
Mm.
What are these two? How can they relate it to the current chapter?
Oh, they're like ax plus bx equals c, x plus minus bx equals c. Lines. They're lines.
How many variables are there? Total?
Uh, we have 3 variables.
How many?
3.
It is just two.
Okay, so SC and SW.
Yeah. SC means not C into S, not like that.
Yeah, I got it.
C is just subscript.
Yeah, okay.
Well, we have to, how many methods to solve linear equations?
2.
So which one would you like to use?
We can just use substitution here.
So which one you want to find?
Let's find the speed of the canoes first.
Yeah, right there.
So you'd have SC equals 6 minus SW.
See, the C and W are
Low, not on par with.
Okay. Okay, yeah.
Yep.
Then we can say 6 minus SW equals, or no, not equals. 6 minus SW minus SW equals 4. So 6 minus 2 SW equals 4. Minus 4 minus 2 SW equals minus 2. So we can negative 2. Oh, well, wait. Divide that by negative. Mm, am I on the right track so far?
Yeah, of course. How much is SW here?
It would be equal to, this cancel out. Well, no, negative 2 divided by negative 2 SW is equal to 1.
1. So now that you found SW, what else you need to find?
The speed of the canoes
How much is
would be SC plus 1 equals 6, minus 1 SC equals 5.
5? So the SC means 5 means. What is SC?
Speed of the canoes,
What about this?
that's the speed of the water.
Okay. So that's it.
Yeah.
So there are two terms which are called upstream and downstream. When he is going down the river, it is called downstream.
Yeah.
So it's like going on flow with the water current.
Mhm.
And when he is going against the tide, it is called upstream.
Okay.
So that is about that chapter. And so these are some word problems when it comes to linear equations and systems. And we also discussed so far regarding the solutions. These 3 points are extremely important. Okay, let's do one more question.
Okay.
Let's say there is a system of linear equations given.
Mm-hmm.
The question is actually which method is more suitable and justified.
Oh, okay. Um, hmm. Mm, I think I don't really want to deal with so many fractions at once using the substitution method, so I feel like elimination would be a little simpler here.
Good. So elimination is the right answer. I mean, more suitable answer. You can also do in substitution, but elimination is more convenient in this case.
Yeah.
And what did you notice about the first one and second one?
So this is at a ratio of 1, 2, 3. Then this is at a ratio of oh, this is at a ratio of 3, not 3 to 1. Yeah, it's this is also 1 to 3. Yeah, 1
Is
to
that ratio
3.
equal?
Yeah, this is equal to this. So this would be like but this 1 to 3 does not equal whatever this is.
See, look, check this ratio again.
Oh, wait, it's minus and plus, so. Or wait, no, it would be the other way around. Um, yeah, isn't this 1 to 3? Because if this is being divided by 3, and we take out the dividing by 3, then it would give you this, so it would be 1 to 3, right?
See, do it properly. How did you get this first? Tell me that.
Well, this was simple because it was the same thing, and then we just added the 3 here.
So is it like 1 by 2 divided by 3 by 2? The first one.
Uh,
Coefficient of x.
yeah,
This will be
3 over 2, or 1 divided by 3 over 2.
it's just 1 over 3.
Okay.
See, you can write it as 1 by 2 times 2 over 3. You flip this denominator. What do they go?
Mm.
Like this.
Mm.
Do you understand? Yeah.
Yeah.
Y coefficient ratio is
Negative 2y divided by 3 divided by 2. So negative 2 divided by 3 divided by 2.
it will be
Um, mm, negative 1 over 10.
see 2 means what? 2 by 1, right?
Yeah,
So 2 over 3 into 1 over
3.
2.
Oh, 1 over 2. Yeah, sorry.
You flip this.
Yeah, yeah.
Okay.
Yeah.
Are these ratios equal?
No,
So A1 by 2 is.
it's not equal to b1 by.
So how many solutions?
You would have one solution here.
One solution.
Yeah.
Okay, one more thing to notice is
Mhm.
if you multiply the above equation by 3, what do you get?
You would get 3x divided by 2 minus 3. Uh, it would be 2 minus 2y equals 7.
And what is this?
Oh, it would be times 3, you're saying?
So basically, this thing spans 3.
Oh, okay. So then it would be,
If you add these two equations,
yeah,
what do- what will be eliminated?
3x divided by 2 minus 2y and plus 2y. Oh, The minus 2i would be eliminated.
So if you add, so x is equal to 7 by 3 plus pi by 9.
Yeah.
This is how you can get x. And then for y, how do you find y?
You input it back into the, like if we know x equals 7 over 3 plus 5 by 9, then we can just input it back into the.
Yeah, you put the value of x in any
Yeah.
equation, you get y. So elimination is the convenient method. Well, let me talk some basics regarding fractions. Let's say if I say 1 by 2 divided by 3 by 4, this is
4 over 6, 1 and 1/2. No, not 1 and 1/2, 2 over 3.
see 4 over 6 is the correct answer. It is 1 by 2 divided into
Times 4 over 3. 4 over 6.
or 2 by 3. Let's say 1 over 2 divided by 3.
It would be 1 over 2 times 1 over 3.
Like this, right?
Yeah. Yeah.
Let's say 1 divided by 5 by 6.
It would be 1 over 1 times 6 over 5. It would be 6 over 5, basically. Yeah.
So the thing is, you need to notice one thing. This one. The length of this is actually greater than anywhere else. Do you see the difference?
Yeah.
This signifies that you have to treat above this as numerator and below this as denominator. This means in this case numerator is half, denominator is
3 over 4.
just 3. This one.
Oh, sorry. Yeah, I was looking at the top